All right, so we're going to start chapter 3 here. And so this chapter is mostly about learning how to differentiate various types of functions. And as you can see from the title of this section, we're going to learn some shortcuts to finding derivatives. And so you might wonder why we were wasting so much time doing derivatives the long way. But part of that's just kind of help reinforce the concept of the derivative, which is taking an average rate of change and shrinking that interval down to where it's instantaneous rate of change. But there are shortcuts that we can use to find derivatives pretty quickly of much more complicated functions. And I think if you learn these rules, then pretty much any of the functions that we look at are not going to be too difficult to find. But if you were using the limit definition that we've been talking about, then they would be quite difficult or even impossible to find. Maybe not impossible, but I mean, not nearly worth the trouble. So this section is learning shortcuts, and these are just kind of rules that you'll probably need to memorize. And this first one, I think if you go back and look at the examples that we did in the last couple of sections where we did the limit definition, um, you would probably could notice how this rule comes about. But all this one says is if we have a power function x to whatever exponent, could be any real number, to get the derivative of that, d over dx. Essentially what you do is, in my mind, and this is kind of how I think about it when I do these, you bring this exponent down as a coefficient, and then you subtract 1 from the exponent to get a new exponent. So just a couple of simple examples here. F of x equals x to the 6th. So the derivative f prime of x, we're going to bring the 6 down in front. And then we have x, and then we're going to subtract 1 from the exponent. So that's 5. So 6x to the 5th. X to the 1000th. So y prime would be 1000 x, and then we subtract 1 from the exponent, so to the 999th power. It really is just that simple. T to the 4th, p equals t to the 4th. So we could write this, we'll write this in the other notation that we had, dp over dt. So again, this is the derivative of the function p with respect to t. So bring the 4 down in front, subtract 1 from the exponent. That is it. That is as easy as it gets. We could look at other ones. These are would also be considered either power functions or root functions, I guess. But the same rule applies. The only difference with these is, like with this one, I always recommend, especially when you're getting used to these, always write the x in the numerator and then adjust the exponent by making it negative in this case. And then you can use the power rule. So you don't want to use the power rule based on this. So we're not going to bring the 2 down there and then subtract 1 from the exponent. It doesn't work like that. But now that we've written it like this, we can take the derivative using the power rule, bring the negative 2 down, and now we're going to subtract 1 from the exponent. So negative 2 minus 1 is a negative 3. And then if you want to, you can rewrite this so that it's similar to the original form, but you don't really have to do that. Then the next one, so with radicals, I would suggest you write this with an exponent. So the cube root of x is the same as x to the 1/3. So now let's take the derivative of that. So all we do is same thing we've been doing, bring the 1/3 in front, and then subtract 1 from the exponent. So 1/3 minus 1 would be negative 2/3. And we'll just leave that one there. You could write it more like this if you wanted, but you don't really have to. And then last one, so we're going to write this one as t to the negative 1/2. And then take the derivative, just do the same thing. So we bring the negative 1/2 in front. Subtract 1 from the exponent, negative 1/2 minus 1 would be negative 3/2. And that is it. So that's the basic power rule. And pretty simple, and we'll use it over and over and over again. So it should not be anything too difficult after you do it a few times. So.